Hello dear students, after so many days I came. Last time we have discussed about the fundamental forces in nature. There were two forces we have discussed already. One was gravitational force and another was electromagnetic force. Now let us see the third force is a strong nuclear force. So according to this word, this force is inside the nucleus. What is nucleus? As you know the definition of atom, the central part of an atom is called a nucleus. What is an atom? The smallest fundamental particle of any substance is known as atom. And the central part of the nucleus, central part of the atom is called a nucleus. Here I have taken the nucleus of uranium-92-238. This 92 indicates number of protons. 238 indicates protons plus neutrons. To get the subtraction of 238 and 92, you will get 146. The uranium nucleus is made up of 92 protons and 146 neutrons are there. Actually, according to Coulomb's law, what can happen? Between proton, positively charged particle, there is a repulsive force. That's why all the protons will try to come out from the nucleus. It means what? The uranium nucleus should become unstable. But we know these kind of the protons are not easily coming out from the nucleus. This fact indicates over and above this Coulombian repulsive force between protons, there must be another kind of strong force of attraction is there. And this force of attraction must be stronger than the repulsive force according to Coulomb's law. And because of which all the protons inside the nucleus would like to remain together. So here from the experiments it has been found that this kind of the force of attraction not only exerting between two protons, it also exerts between two neutrons. It also exists between one proton and one neutron. And this kind of the force exerting between either two protons or between two neutrons or between one proton and one neutron inside the nucleus is known as a strong nuclear force. As far as this strong nuclear force is concerned, there is no importance of positive charge of proton and zero charge of neutron. That's why this force is said to be charge independent force. What's the definition? The definition is like this one. The charge independent force acting between proton-proton, proton-neutron and neutron-neutron within the nucleus very strongly is called what? A strong nuclear force. Now let us see the properties. As the word is there, strong, so you can see the first property. It is always be attractive in nature. Second one, it exists within the nucleus. Outside this nucleus, protons and neutrons are there. Then there is no question about the force of attraction. Unless and until they remain inside the nucleus, this force is there. So it exists within the nucleus. It is a short range force. So until the proton and neutron remain inside the nucleus, until they remain within the distance of 10 raised to minus 15 meter, the force is there. That's why it is a short range force of the order of 10 raised to minus 15 meter. And it is strongest out of all these fundamental four forces. Then how much time it is stronger? So you can see this force is 100 times stronger than the electromagnetic force. If you take two protons outside the nucleus, Then according to Coulomb force, you find the force between them. Then again you consider the same two protons inside the nucleus. Find the force, you compare. You will find this force, strong nuclear force, is 100 times stronger than the electromagnetic force. This force have other name. It is also being known as a quark-quark force. Why you say it is a quark-quark force? Because new researches are saying that the protons and neutrons are nowadays not be the fundamental particles. They are made up of some new more fundamental particles. Which more fundamental particles? So they are known as the quarks. There are two types of the quarks. One is called up quark, another is called down quark. Up quark having a charge plus 2 by 3. Down quark having a charge plus 2 by minus 1 by 3. So when the force between two proton or two neutron is there, then this force ultimately results in between the quarks, and that's why this force is also being known as a quark-quark force. And last property, it does not act on electron because this force acting between protons and neutrons inside the nucleus. Electrons are outside the nucleus. That's why this force does not act on the electron. So here, be remember this point. Thereafter we come to the next topic. It is a weak nuclear force. So what is the fourth characteristics of the weak nuclear force? Be remember, these kind of the forces are always be arising in a certain nuclear process. There are so many nuclear processes, alpha decay, beta decay, gamma decay, out of which we are considering only the one nuclear process, beta decay. And this beta decay process takes place from any radioactive nucleus. Radioactive nucleus like uranium. If a nucleus like uranium, radioactive nucleus emitting beta decay means what? So in the beta decay, the nucleus emits an electron and a chargeless particle called neutrino. So be remember, the weak nuclear force arising only in certain nuclear processes such as the beta decay from radioactive nucleus. In the beta decay, the nucleus emits an electron and chargeless particle called neutrino. About this emission of beta decay you will study in 12th standard. Then at that time of beta decay, means at the time of electron is coming out from the nucleus as well as neutrino is coming out from the nucleus. So here there is an interaction between the electron and neutrino. And this kind of the interaction between the electron and neutrino, which are coming out from the radioactive nucleus in the process of beta decay, is known as what? Weak nuclear force. So definition is the force arising due to interaction of neutrino with other charged particle like electron is called what? A weak nuclear force. According to its name, weak nuclear force is the weakest force, but not too much weakest. It is slightly stronger than the gravitational force, but weaker than that of electromagnetic force. So you can see again, this force is a short range force. So unless and until the electron and neutrino are coming out from the nucleus, the force is there. As soon as they come out from the nucleus, then there is no force. That's why this force is within the range of size of nucleus, that is of the order of 10 raised to minus 16 meter. This force is stronger than the gravitational force, but much weaker than that of the electromagnetic force. Now let us see. The next topic is towards unification of forces. So earlier we have studied about the four fundamental forces. After this topic we will see the comparison between these four fundamental forces. But before that you see the towards unification of forces. Means what? Actually here the scientists are going to be finding about the origin of all these four fundamental forces. They are believing that these four fundamental forces can arise from a single force or not. So for these purposes, the different scientists have tried to combine this kind of the forces and try to get the expected result. And here, that's why the topic is unification of forces. So which scientists have tried and which expected result they have got. So let us see. First time, Isaac Newton have unified celestial and terrestrial mechanism so that the same laws of motion and laws of gravitation apply to both the domains. Celestial mechanism, that means the object which are in the space, like planets which are revolving surrounding the sun. Terrestrial, all the objects which are lying on the earth. We have these kind of the two domains are. One is celestial domains, another is terrestrial domains. On all these kind of the domains, you can apply common law of gravitation, and according to which you can determine the force of attraction exerting between them. So thus, celestial domains and terrestrial domains have been unified by applying the common law of gravitation, and that have been proved by the scientist Isaac Newton. Then another one, the experimental discoveries of Ørsted and Faraday. We remember these are the two great scientists of electromagnetism. Most of the experiments regarding electricity and magnetism have been performed by these kind of scientists, and they have unified the two branches of physics. One is electricity, another is magnetism. So the experimental discoveries of Ørsted and Faraday showed that electric and magnetic phenomena are in general inseparable one. Electric phenomena depends on magnetic phenomena depends on electric. So they have combined the electricity and magnetism. Then Maxwell have unified electromagnetism. Electromagnetism, that means electricity and magnetism. Common name is electromagnetism. So Maxwell have unified electromagnetism and another branch of physics, optics. How? With the discovery that the light is an electromagnetic wave. So thus these two kind of the branches of physics have been unified. One is electromagnetism, another is optics, with the discovery that the light is an electromagnetic wave, and that have been done by the scientist James Clerk Maxwell. Then Einstein have also attempted to unify the gravity and electromagnetism, but he was not succeeded. He was failed. That's why his attempt was very good, but not succeeded. At the last, Glasgow and Salon showed that the weak nuclear force and electromagnetic force could be viewed as the different aspects of a single electroweak force. It means single electroweak force is the combination of two forces. One is weak nuclear force, another is electromagnetic force. So these were the topics of towards unification of forces. And now let us see the comparison strength between these four fundamental forces. This is also very important. The first one is, here you can see that name of force, relative strength, range and operating amount. The gravitational force is there, as you know, it is 10 raised to minus 38 Newton. How is it come? So first of all, I consider the magnitude of strong nuclear force. Strong nuclear force is 1 Newton. Then As we have seen, what's the relation between strong nuclear force and electromagnetic force? Strong nuclear force is 100 times stronger than electromagnetic force. So I can write here Fs equal to 100 and 10 raised to 2 into EFE. So what will be Fe? 1 upon 10 raised to. So this implies electromagnetic force is equal to 1 upon 10 square Fs. 10 square, that means 10 raised to minus 2. Fs is there. So if Fs is 1 Newton, then electromagnetic force is 10 raised to minus 2 Newton. We have seen also earlier the relation between gravitational force and electromagnetic force. The electromagnetic force is 10 raised to 36 times greater than that of electromagnetic force. So now by putting that value, you can determine here, again taking electromagnetic force is 10 raised to minus 2, this can be written as 10 raised to minus 38. So on the basis of this fact, you can see that if strong nuclear force is 1 Newton, then electromagnetic force is 10 raised to minus 2 Newton, weak nuclear force is 10 raised to minus 13, and gravitational force is 10 raised to minus 38 Newton. So this is the strength or magnitude of forces with respect to each other, and that's why it is relative strength. So gravitational force relative strength is 10 raised to minus 38 Newton, range it is infinite. Why? Because it exerts between all the objects in the universe. If you take one object in India, another object in US, and then also in between them there will be a gravitational force. That's why the range of gravitational force is infinite, and it operates between all the objects in the universe. Similarly, weak nuclear force, magnitude strength 10 raised to minus 13, it is very short. Why? Because it is within the nucleus. That's why the distance is approximately nuclear size 10 raised to minus 16 meter, and it acts between what? It acts between electron and neutrino. So these electron and neutrino are said to be what? Elementary particles. Then electromagnetic force, relative strength is 10 raised to minus 2. Range is infinite, and it acts between all the kind of the charged particles, proton, electrons, etc. there. Again, it is a long range force, that's why this range is infinite range. Then strong nuclear force. So strong nuclear force relative strength is 1. It is again very short range. It acts between the neutrons and protons. These neutrons and protons have common name, nucleon, as far as the strong nuclear force is concerned. Just like students. So what is student? Who is the student? Student may be boy or a girl until the boy or girl is going to be learning from the side of teacher. Then they are said to be the student. The student may be a boy or a girl. Same way, the neutrons and protons are known as nucleons as far as this strong nuclear force is concerned. So here, the strong nuclear force is relative strength 1 Newton. It acts between proton and neutron until they remain inside the nucleus. That's why the range is very short. So within the size of nucleus 10 raised to minus 15 meters. Okay.